Hey, hi, good morning, everybody. Am I audible? One of you, please confirm. Hello, am I audible? Guys, Myra, am I audible?
Yes, sir, you are.
Okay, okay. Thank you, Balkrishan. Fine. So here today we are about to start F5 DNS, right? Let me open my whiteboard and just start up with our F5 DNS topic. But before that, let me tell you, I would be starting it from the scratch. Okay. If you guys have some doubt, any question, you please stop me then and there. I will try to resolve it. Okay. And if you wanted to touch some another topic, you can tell me that okay, such and such topic we can touch in this free webinar. I am happy to touch that topic. Okay. And we'll give you the overview for the same. But since I am not aware about all the audience, their background, I would be starting from the very basic zero level. Okay. Now, if you guys are aware about DNS, right? Everyone is aware about DNS functionality. I will say coronavirus was the time when the industry was getting redefined totally. There was a very mass shift that every company was trying to move quickly over the internet, right? And this shift was accelerated worldwide, okay, not with respect to the some specific country. So at the same time, when somebody is opening a new company in over the internet, I will say, or over the internet presence, let us say there is an organization, ABC. They wanted to come on the internet. Okay. First of all, they need to buy some space over the internet, right? So where they will go? They will go to the registrar, right? And from maybe there are lot of domain hosting websites, right? GoDaddy and all of those. Even Google also sells the domain. They will go to such of these registrars and will say that I need some name. Let us say this name is free for them. Okay, www.abc.com. So what they will do, they will purchase this domain from the registrar. It can be any registrar. Okay, so when they are buying such domain, right, what registrar will do? That will book this domain name for the specific customer ABC. Okay, for maybe 3 years, 5 years, whatever the plan you are buying. After that, this domain can be free if you are not, repurchasing it. Now, when you are purchasing this domain, you will also receive some IP address. Just hypothetically, I am taking very simple IP address 1.1.1.1. Okay. So this domain will have one IP address 1111. After that, maybe these engineers are asking their designing team to deploy a website for this specific domain. That is how very simple business comes on the internet. They show their presence over the internet, right? Main thing is now when client will come, okay, any client wanted to talk to abc.com, www.abc.com. The whole process will happen. How? Whosoever this client is, they will connect to its modem, right? Because in house we have some modems maybe from Airtel or any other ISP, right? This modem act as an default gateway and something named as LDNS. L stands for local. So local domain name system. So this modem act as an LDNS. So what happened is when somebody type this name abc.com in their browser, this will get checked in the browser cache. If this entry is not available there, it will be get checked in their system cache. Let us say it's not available there also. Then it will send to their LDNS, which in our case is the modem. Right? Now, after that, modem will send this query because if in the last, if you see, there is .com. What happened is, in case of DNS, resolution happens from right to left. Okay. So whenever we are writing down any name like Netminion, .net, there is a hidden dot afterwards. Okay. There is a hidden dot. This dot represent to the root server. This is named as a root server. There are many studies which used to say that there are 13 root servers deploying in different countries, managed by different companies, starting with the name A to the M, bit like that. But there are more than 13, I will say. Okay. So how your query will get resolved from right hand side to the left hand side. So when a user is trying to open www.abc.com so your LDNS will send this query to the root server. Root server means just dot root. Why? Because DNS adopt a reverse tree architecture. Like on the top, there would be a root, okay, dots or the root. Post that, there can be .com, there can be .in, there can be .net, .org, or blah, blah, blah. After that, this tree structure would be keep on growing. Okay. So it inherit a reverse tree architecture. So again, my query will go to the LDNS. From LDNS, it will go to the root server. And since root server will never resolve your query, never ever resolve your query, what it will do? It will refer this query to the next part. And next part is .com. So it will tell, bro, go to the .com. Okay. Then your LDNS will send this query to .com. Okay. Again, .com should have this entry abc.com, as I was telling you that somebody if need to open a company, they need to go to some of the registrar or some of the some of the authority to get these old stuffs ready. So .com is aware that even I am not aware about this IP address, but I can refer you to the proper DNS server. Let us say he bought it from the GoDaddy. Okay. So this query will go to the GoDaddy. And GoDaddy is aware about this IP address. It can give the correct IP address, maybe 1.1.1.1. And that is how your packet will get formed, right? To make your packet pass through, it should have source IP, destination IP, then source IP of your destination and destination IP of your destination. So it is your source and it is your destination, right? So destination source IP and destination, these all terms need to be get clear to have the packet flow end to end. And that is where we are receiving the IP. Okay, now let's proceed. Any questions in this specific flow or diagram what I created? No? Okay. So basically, when we are talking about DNS, simple means name to the IP resolution, right? And this work on the UDP port 53. Okay, just FYI. If you talk about a little bit history of DNS, earlier we were using some host files. Okay, it still resides in our system. Okay, if somebody wanted to make changes into their host file, that will get precedence. Okay. Your entry will not go to the LDNS to check. Why? Because within your system, that entry has a specific IP address associated. So it will get resolved. So very first, in 1970s, one solution was find out before the DNS, I will say, that was host file. But as internet grew very rapidly, very fast, it was really an unmanaged solution and it was not a scalable solution. So we come up with some of the solution named as bind. Okay. This is a utility, I will say, on the Linux server that you can download a bind utility where you can implement your local DNS server. But in bind also, there are a lot of limitations. And going forward, we went for DNS. And in the DNS, we are going to talk about FIDNS, right? So FIDNS is intelligent DNS resolution. Very intelligent DNS resolution is FI. I am just touching the FIDNS, like why this come into the picture that I am describing. So earlier I talked about that a user is going for some of the query. It will go to the root. It will go to the top level domain. It will go to the second level domain or bit like that. Root means dot. Top level means like .com. Maybe here server.com. Okay. And even before that. Further, it is going to some authoritative DNS server. And in this case, the authoritative DNS server is FIDNS. So there is a query like abc.server.com. Okay. This query is going to the FIDNS. Here FIDNS will listen to this query on the UDP port 53. And are you guys aware about LTM? Yes or no? Anybody? No? Very silence. Okay, it's all right. So what happened is on FIDNS, we have something named as listener. Okay. Listener is bit like a virtual server. Like in LTM, you listen the traffic on the virtual server. Similarly, here you listen the traffic on the listener. When listener receive the DNS traffic, it will invoke a GMTD process, which means FIDNS will see, does I have the entries for this specific website or not? And entries can be of multiple ways, like it can be through intelligent DNS resolution, or it can be through accelerated DNS resolution. Okay, I am coming to this slide in a moment. First, I need to talk about these two terms, otherwise you people will get confused. So this is a user. User wanted to go to the abc.com, and this is a data center of abc.com. Here they have a DNS, dedicated DNS. Okay, maybe on the Linux server using the bind utility, right? It will check that, okay, abc.com entry I have, there is something, some file named as zone files. In the zone file, there should be a record. A record means like abc.com should have some IP address over there, 1.1.1.1. So it will see that, okay, I have a zone file. In that zone file, I have a record. In a record, this is the IP address. It will give the IP address back to it, 1.1.1.1. Now, you want to scale your data center. Okay. This is old situation. In the new situation, when this client is coming, this client is going to F5 DNS. And after FIDNS, it might possible that you are not resolving your old bind server. That is as it is. So I just added one more thing, that is F5, right? Now When such is the scenario, your FI DNS is not the only DNS server in your environment. It might be depending upon an authoritative server, and this is acting as non-authoritative. By the way, I am using these terms non-authoritative, authoritative. Let me give you an overview. What does it mean? Okay. So let us say if you are going over here, I am just going to the interactive lookup, NS lookup. I am just going for maybe netminion.net. Can you see it is a non-authoritative answer, right? Google.com. It's a non-authoritative server, right? Facebook, Facebook.com. It's a non-authoritative server, right? What does it mean? It means that actual DNS server, we are not aware about the same. We are offloading our DNS services to somebody else, whereas we are hiding our actual DNS server. If a client is going to the actual DNS server, this answer will be an authoritative answer. But in this case, because this answer will be provided by the FI DNS who is not maintaining the zones for abc.com, the answer will be non-authoritative. Guys, any doubt, any question? No? Okay. So in this scenario, when your FI DNS is liaising on some other DNS server, this kind of behavior is named as accelerated DNS resolution, which means ultimately the client is coming to FI DNS, but FI DNS is not doing everything by its own, which means we are not fully utilizing FI DNS, and we are just maybe through the DNS Express, maybe through the listener on the pool, or these are different settings. Depending upon those settings, we are asking somebody else to provide us the DNS resolution. And after that, we are providing this answer to the client. Now, let me go back to my previous slide here. If you see, I was just talking about that a client is trying to resolve abc.com. Okay. And here it went to the root, top level domain, second level domain, go to the authoritative DNS name server, which is our FI DNS. FI DNS can resolve it intelligently, or it can do the accelerated resolution. Intelligent DNS resolution will come into the picture when we configure something named as wide IP. Okay. So this is a configuration named as wide IP. Wide IP is bit like maybe you can say a virtual server, or but here we only have name, no IP. Wide IP can have different pools, bit like your virtual server of LTM. And in the pool, there can be different pool members. Okay, that is how your general traffic flow will happen in FIDNs. Okay. Now, let me give you an overview. This is FIDNs. In FIDNS, this is my data center 1. This is my data center 2. Okay, you need to understand first one thing. When client is trying to access abc.com, first it is going to the DNS to get the IP. Let us say it received the IP 1.1.1.1. This IP is what? This is app server IP, application IP. So after that, application traffic will come onto the data center to access the application. So it can be your HTTP, HTTPS traffic, and this traffic is purely DNS traffic. So we need to understand there are two flows which are going hand in hand. Okay, so we are talking about only DNS flow here, not about the application flow. So I'm just starting from again. This is our client. client is coming to FIDNS, and FIDNS, but obvious need to have some resources. Let us say this is my APAC data center. This is my EMEA data center. In APAC data center, there are my some of the servers which are running in. These are my servers. Both of these servers are hosting a website xyz.com. Here also, here also. That is a journal flow. And before that, there could be our LTM, which is sitting. Here is our LTM. And before the LTM, there is a virtual server. Let us say this is virtual server 1. Let us say this is virtual server 2. Okay. So in actual term, when traffic will come over my virtual server, okay, when any application traffic will come to my virtual server, there would be a load balancing. And depending upon the load balancing, the traffic can go. Similarly, if traffic will come on my email virtual server, again, there can be a load balancing and traffic will be come to one of the backend pool member. That is how your traffic will flow. Now, what we would be going to do, we need to check that the traffic should go where, right? And that is our DNS come into the picture. Like here, IP can come for virtual server 1, IP can come for virtual server 2, because both of them are hosting the same website. So when this user is trying to come for xyz.com, this request will go to the FIDNS. Now, FIDNS is named as Intelligent DNS Resolution. Why? It will check this user is coming from where, right? Let us say this user is coming from UK, which means this user need to go to the EMEA data center. This kind of load balancing your F5 will do. Okay, your FIDNS will do. So FIDNS will say that, okay, when this user is coming from UK, with respect to the latency, with respect to the user performance, I am sending it to the virtual server 2. So here IP will be provided. Let us say virtual server 2 has the IP 2.2.2. Virtual server 1 has IP 1.1.1. So this user will be get provided with the IP 2.2.2. Okay. Another user, same application, xyz.com, coming on your FIDNS, but this user is from India. Okay. Now, when this traffic will come onto your FIDNS, it will see that, okay, what is the user location? And depending upon the user location, a pack is the correct data center which it should go to. It will send the IP 1.1.1 for the same application. There are different IPs which are gonna provided by your FIDNS. And this is what I am giving the view of GSLB, Global Server Load Balancing. When you are doing the load balancing across the global or across the different data center. I'm just giving you an overview, guys, but if you will pick the questions, I'm happy to answer over here. There are a lot of things which I can include, but I am not aware about my audience background. So you need to tell me either you are understanding, or if you have any questions, I will answer then and there. Okay. If no questions, fine. Yeah. Balkrishan, you are asking some question?
No, sir. Till now, no question.
Sorry, Ashram.
I'm saying uh, uh, till now, I have no any questions. I'm getting the all point that you shown on diagram.
Okay. Thank you. Thank you for your confirmation. Now, let me show you when we will teach these classes. Okay. We would be gonna opt for some of the practical, and that practical, this lab, you all people will receive who will register with us for the actual classes. Okay. This lab you will get able to access over the internet. Okay. 24/7 as per your need. What you need to do, you just right click over here, start this device. This device will get started. Similarly, we have GTM, we have LTM. Okay, these devices you can just start. You can put like double click over here, and this device will open for you. Okay, so if you see, it is starting your Windows device. Now, in this lab, if you will see what we are doing, we are creating two data center, like EMEA data center, APAC data center, right? Here you can see there is one GTM, there is one GTM, right? And in the last, we will do the GTM sync. Okay. So GTM sync is bit not actual your like your LTM, right? In your LTM, there is a separate story. But here there is something named as sync group. So both device will show you as active. Both device will show you as active standalone, whereas in the sync group, they would be syncing every single configuration with each other. Okay, so that practical we will do in the last, but let me start from where we will gonna start. So here we will be installing bind on these servers, Linux servers. We will install the bind utility. Then we will create the zone file. We will create the forward zone file. We will create the reverse zone file. So forward zone file means name to IP. Reverse zone file means IP to name. So you have seen multiple times during the troubleshooting, there is a requirement that you have server1.com. If you need to do the trace of server1.com, what are you doing? You are doing the reverse lookup, right? So it means when this trace will happen, maybe this IP is 192.168.1.105. So the trace will go for such a particular specific IP address. So similarly, we would be gonna create forward zone, we would be gonna create reverse zone, and we will see how this client will able to resolve my own domain. So I will create a new domain over here, and as per that domain, probably I would be gonna play around my different name resolutions. Then we will boot up the GTM. In the GTM, we will create the listener objects. We will make the accelerated DNS resolution. In the accelerated DNS resolution also, we have plenty of options. Like we can use R cache, T cache. We can use maybe DNS Express. Okay. And there are a lot of things which we need to play around for the accelerated resolution. So that we will check over here. And then, but obvious, we will be gonna talk about our intelligent DNS resolution, which is creating a wide IP. And using the wide IP, we will leverage the actual functionality of our GTM box. So during the wide IP also, there are a lot of things which will come into the picture, right? Like the main thing is load balancing. Why load balancing? Let me tell you over here, because I was describing you one thing over previous slide here. Let me repeat it again. In your FIDNS, you create something named as wide IP. Okay, wide IP can have something different pool. I am just creating two pool. There can be many. Every pool can have different pool members, right? If you talk about FIDNS, your load balancing will occur at two levels. First level at on your wide IP. Why? Which pool to choose? Pool number 1 or pool number 2? First load balancing. So there are total 4 load balancing mechanism which will come into the picture, like global availability, round robin, topology, and round robin, global availability, and ratio. These are the 4, okay, which will come on your wide IP level. Then once your wide IP is selected, let us say you come into the pool 1. Into the pool 1 also you have two options. Either you can go to the pool member 1 or pool member 2, right? So again, the load balancing will come into the picture here. which is on the pool level, where you have plenty of methods available. Some of them are static, some of them are the dynamic, and that is where whole story begins, right? So it's not only to create an wide IP and assign a pool. There are a lot of things in the background. Then when you are trying to add a sync group, what I was mentioning about the sync group, right? So when you are trying to create a sync group between your first device to your second device, there are some scripts, okay, ready-made scripts, which you need to write down or you need to run down. So if you run that script on your old device, it might happen that your all of the configuration wiped out. Why? Because those scripts have some standards, some, maybe I will say, ideal scenarios, like where you need to run those scripts. If you are not running that script on the correct devices, your whole DNS infrastructure can collapse. Okay. And you are aware that how important your DNS infrastructure is. So we need to be very much aware, like which script work for what kind of device. For LTM, there are different scripts. For GTM, there are different scripts. And into your GTM, you can go with your LTM as a server. You can just have a generic host. You can have maybe some another LB. So all of these permutation and combination, we would be gonna discuss during our class. If you wanted to see the syllabus, probably I will say go to our website, netminion.net, right? Scroll down, go to the F5 GTM. Here you can see the previous recorded videos also, and you go down. Here, just click on this download syllabus, and you can able to see what all syllabus we would be gonna touch, right? Any question, guys, so far? Any doubt? Any topic you want me to touch? Okay. If not, let me just conclude by talking about one or two uh, things. First thing, this class will be from starting from next weekend, Saturday and Sunday. Each day, we will be consuming 2 hours. Total, approximately 5 to 6 weeks, we would be gonna touch. Okay, which means approximately 5 into 4, 20 hours, 18 to 20 hours would be the total course duration, I will say. Okay, so that is how we will be running these classes. If you are interested, you please approach us. Okay, you can approach Myra or you can go to the website. Okay, here you can just go to this WhatsApp button and you will reach to us. We can handle your inquiry. Okay. If no questions, maybe we are good to wrap it up. If you have any doubt, any type of question, feel free to ask. Sure. I am thinking that there are no questions. Very intelligent audience I have today. Okay. So great day. Thanks for your time for joining in. Okay. We'll meet you in the classes. Till then, thank you and have a great day. If you are interested for F5 APM, our next lecture free webinar would be starting in next week for F5 APM. Also for SD-WAN and BGP as well. So would like to see you over there also. Thanks a lot. Have a great day. Take care.
Thank you,
Happy
sir.
weekend.
Thank you.